So as you guys can see here at the top, I put where you can find it in your notes if you need to. But for this one, we're being asked to solve the equation with the quadratic formula. Quadratic formula is this guy here. And the 3 is the A, the 9 would be the B, the C would be 5. And so just basically plugging stuff in. Let's go ahead and do that real quick. So we have B is 9. I like to start off actually with just a whole bunch of blanks. The reason I do that is because I find that students make a lot of times errors with negatives and stuff. So when you start off by rewriting with everything in place already and just plug numbers in, it kind of avoids that error. So 9 here, 9 here, that's my B value. A goes there, which is 3. And A also goes here, and then C is 5. And from here, you just got to watch your order of operations a little bit. You should do your exponents here first, right? So it's going to be 81, and this is going to be 60. Okay. 81 take away 60 is what? 21? Okay, so what I'm a little bit sad about with this example is you're not getting a chance to see some other things. Some things you want to keep in mind is sometimes you have to break down the square root, right? You have to break it down, take out the pairs, that kind of stuff. Another thing I want you guys to be aware of is that after you break it down, you don't need to, this is the answer, we're good here. But after you break it down, let's say you broke it down and you ended up with something like this instead. Let's say 6 plus or minus 8 square root of 2 over 12, right? Let's just say you had that. Well, in that case, you also need to reduce these 3 numbers, okay? Not the square root, huh? Good point. So Xana pointed out, looking at this answer here, we had this, right? It was 6 on the bottom? Yeah. So I know that you can reduce 9 and 6. The problem is that there's a number here also. It's a 1. And you can only reduce the top if you reduce everything on the top. And so we can't reduce the 9 only. You would have to be able to reduce it with this number also. And so since it's just a 1, we don't. So I'm glad you mentioned that. Anyway, so there it is. So that's the quadratic formula. What I'll do is I'll pause here and let you guys work on maybe 1 or 2 of these for a couple minutes, and then I'll move on to another question, okay? All right. Not sure if you guys, were tracking, but Amanda, you were asking, so I think that's what you had. That's good. And then here's the last one. I'm not sure if that matched yours or not. Okay, good. So anyway, so that's one thing you guys will be asked. Let's go ahead and take a look at the next one here. Now I know you guys might not have finished all 4 of those. That's okay. I didn't expect you to. I just wanted you guys to try one like that, and then I'm going to move on to another topic so you guys can kind of see one of each type of question. The next thing we're going to look at is we're going to look at graphing quadratics. Now, quadratics can come in 2 forms. They can come in this form, which is called vertex form. They can also come in another form like this, which is standard form. The way that you kind of have to go through getting your points is different for each one, but I'll do one of each. So for this guy, it's pretty straightforward, a little bit easier. What you do is you take that number there and that number there, and those make up your vertex. But when you do this, you got to remember you always change the sign of that number there. So it's going to be -2, 3. This number in the front here, this tells you whether you're going to have a happy face or a sad face. Okay, so if it's negative, then you're going to have a sad face. If it's a positive number, then it's going to be a happy face parabola. And in this case, it's a half, so it's a happy face parabola. So I've got my vertex, and I've got my shape, and so from here, all I have to do is go over 2, up 3, put a dot, happy face parabola. It's a multiple choice test, so you should be able to find the correct answer on the basis of those two things pretty easily. Okay? So that's one thing. So that's how you graph a quadratic in vertex form, but how about when you're looking at one in standard form? That's a little bit more work to do. I'm going to actually give you some steps for it. There's only 3 steps, but it's just like it's not quite as intuitive, I think. So the first thing that you're going to do is you're going to find your x value for the vertex. And the way that you do that is with this little formula here. Negative b over 2a. Okay? So in this case then, once again, I like to start off with blanks when I use these formulas. I'm going to plug in 12 to the top, because that's my b value. I'm going to plug in negative 2 to the bottom. That's my a value. Right? Same thing as quadratic formula a, b, c. Right? So in this case, you end up with negative 12 over negative 4, which is 3. So that's the x value of our vertex. The next thing you're going to do is you're going to find the y value of your vertex. The way that you find the y value is you plug that x value in to your equation. Okay, so what's my x value? It was 3, right? So I'm going to put that in here. Now, when you're doing this, you got to remember your order of operations. What comes first? No. What? The square, the exponents are first, right? So you have to do this first. So that would be 9, yeah. And then we'll do the multiplication after that. So this is going to be negative 18 plus 36 plus 15. And that comes out to be, oh, is it minus 15? Thank you, guys. Good catch, good catch. All right, so negative 18 and 36 makes 18. And if I take away 15, I'm left with 3. So there's my vertex. So my vertex now, I got an x value of 3 and a y value of 3. They're not always the same. That was just kind of coincidence. Okay. The next thing that you're going to do is you could really just kind of do it the same way we did the last one, honestly. John had brought up, can you find the y-intercept? And I probably taught it that way the first time I did it, because a lot of times we do want to find the y-intercept for questions. And in case you guys forgot, that's your y-intercept. So you could plot that too if you want to. But we really have enough. I think at this point we just need to pay attention to whether we have a happy face or a sad face parabola. And once again, it's based on whether the A is positive or negative. So in this case, happy face or sad face? Sad face. So we're ready to graph it then. So what's a little bit more challenging about these ones is that unlike the vertex form where you can just look at it and see the vertex, for these ones you've got to plug numbers in and calculate your vertex. But
which one are you doing?
I still got that wrong, didn't I?
Yeah.
It's positive 3, huh?
Yeah.
My bad. So it's right here. Happy face parabola, vertex at 3, 3.
Oh, it's a sad face.
It is? Oh, Mr. Haley. I did it all on purpose. I did. I never make mistakes. I'm one of those perfect people. that was me just quizzing you guys. Sorry. Okay, so you're right. So back up, shake it off. Mr. Bailey was being a butt nugget. So here we go. We have a negative A value, so it's a sad face, right? And my vertex is at 3, 3, sad face. There we go. Now I got it. So it's a 5-step process, if you will. Find your X, find your Y, you've got your vertex, look at your A value so you know how to graph it. Okay? We good? All right, I'll let you try one of them too if you want to. I'll give you a couple minutes for that one. All right, so then we're going to look at some factoring, you guys. So for number 9, let's take a look at a few of them here actually. Let's see, that's 10, 11, 12, and 13. Okay, so basically I included one type of each major type of factoring problem. So when there's 3 terms, you're going to use the box method. Remember that? When there's 2 terms, it might be a difference of squares. Okay? But no matter what problem you're looking at, you should always check for a greatest common factor. So those 3 problems are an example of one of each type of factoring. Taking out a GCF, doing a difference of squares, and a box method. So I'll do all those ones real quick, and then we'll move on from there. So 3 terms is a box method. Your first term goes in the top left. Your last term goes in the bottom right. And what you're doing is you're looking for 2 numbers that multiply to make 5x squared, which would be 5x and 1x, right? And then you're looking for 2 numbers that multiply together to make negative 3. Now, there's a lot of guesswork that goes along here. You know, like, do I put the 3 there and the 1 there? Do I reverse them? And you won't know until you check at the end. And now here's how you check your answer. You fill in your box. 5 times 3 is 15x, and 1 times x is 1x. These 2 numbers should be able to combine to make the middle somehow. Can those make negative 14?
No.
Not right now, but they can if I do what? Make the 15 a negative, right? Which is okay if I make that a negative. So there we go. We got lucky. If I put the 1 up here instead, I would have ended up with a wrong answer and I'd have to just try something else. So it's a guess and check method. But basically we have x minus 3 as the top, and along the side there we have 5x plus 1. Okay, so there's your box method factorization. You do that anytime there are 3 terms. Then we have the next one, which is fun, which is the difference of squares. Notice how both of those are perfect square roots. What's the square root of 9x squared? 3x. So you're just going to split that 9x squared up equally by square rooting it. And what's the square root of 49? And once again, you split that one up evenly. 7 here, 7 here. One's a plus and one's a minus. So anytime you have a difference, it has to be subtraction, a difference of squares, perfect square roots. That's the method you would employ there, right? The last method I would throw at you guys would be the GCF one. This is not a difference of squares. It is a difference. And this one here is a perfect square, but 8's not a square. Okay? And even if it was anyway, you usually start by taking out greatest common factors anyway. So these 2 things do actually have something in common. Both 4 and 8 can be divided by what? 2, but we can go bigger. 4. So we want to take out the greatest common factor, so I can divide out a 4. And they both also have at least 1x, so I can take out an x. So if I divide both of these numbers up here by 4x, I'll find out what's left in the parentheses here if we divide it out, right? So if I divide this by 4x, what would be left? Just x, right? And if I divide this by 4x, what will be left? Just 2.
That's the answer.
Yep, that's taking out a GCF.
Go back to the very
the work. Am I good to erase this, you guys?